In this tutorial, you will learn how to use the Advanced Power module to test the power criterion of the QV protection. The role of the reactive power direction and undervoltage protection, also known as the QV protection, is to disconnect decentralized power plants from the grid if they begin to behave in a way that is not compatible with the system stability after a grid fault. The QV protection device, therefore, monitors the voltages and reactive power direction. The protection device trips when all phase-to-phase voltages fall under a certain value in case of a fault and the power plant is drawing inductive reactive power from the grid at the same time. When it comes to the power criterion, there are two different types of characteristic. With variant 1, the trip range is defined using a reactive power characteristic. In addition, a minimum current criterion prevents erroneous tripping at very low power values. Variant 2 uses a reactive power threshold. You can test both characteristics using the Advanced Power module. In this example, we will be testing a QV protection device using an angle characteristic. The angle is set to 3 degrees. The protection device uses the load reference arrow system. The set value for the undervoltage threshold is 85% of the nominal voltage and the minimum current is 100 milliamps. The trip time is 0.5 seconds. Our Control Center file already contains some test modules used to test other QV protection criteria. The next thing we need to do is add an Advanced Power module to test the power characteristic. The Advanced Power module offers two options for testing in the power plane, the shot test and the ramp test. Both modes offer the possibility of using characteristics defined in the power plane for the test. At the moment, no characteristic is being displayed here, as no characteristic has been added to the test object. We will therefore begin by configuring the test object. The Rio block power has all relevant parameters for the power test ready to be defined. In the Systems Setting tab, we first enter the general parameters. In our example, the star point of the current transformer is set to towards line. Make sure that this setting matches the corresponding setting in the protection device, as it has a significant influence on the power direction. The reference power is required for relative power data. As we are only using absolute powers, the reference power is not relevant for us. In this example, the time tolerance should be 60 milliseconds. For the angle characteristic, the power tolerance is taken from the power angle tolerance. It is 2 degrees. The values for tolerance S absolute and tolerance S relative can be set to 0. The next two sections can be used to define additional voltage and current thresholds. They will be considered during the test. In our example, we will define the minimum current criterion as an overcurrent threshold. The set value of the minimum current is 100 milliamps, and the tolerance is 2% of the nominal current, which is 20 milliamps. The undervoltage criterion will be considered later in our test by defining a constant test voltage of 85% of the nominal voltage. However, we enter a value here to allow for an automated assessment of the test module. If we do a cross-check with a higher voltage value, then the relay should not trip. In the next step, we will enter the power characteristic. First, we enter a new trip zone. Double-clicking on the table entry will open the Characteristic Editor. Here we can add a predefined zone. We need a blinder of 3 degrees. The minimum reactive power is 0 var. If your protection device uses variant 2, the reactive power threshold, you can enter the characteristic following the same principle. simply enter the value of the threshold into the min-q field. In this case, the angle is 0. To finish defining the characteristic, we enter the nominal trip time of the zone. In the next step, we will configure the hardware. For the test, we require 3 voltages and 3 currents. We select the trip as the signal in binary input 1. We do not require any binary outputs for the test. Now we can set up our test.